So next we have Sudipto Das from Amazon. I think it's going to be, I expect, I haven't seen the talk, but very different. So far we've heard about Carbon, CPOs and networking, distributed ML workloads. And Sudipto is going to tell us about data.
Yeah, I hopefully this is something that you find an intersection with. So we benefit, and I'm a database researcher, practitioner, engineer, and we benefit a lot from many of the innovations that happen at the lower layers. And I'm going to talk a bit about some of the innovations that come in the data tier, benefiting from some of the innovations that happen in the lower tier that many of you are presenting, and how some of these data innovations are helping contribute to advances in machine learning or driving more advanced insights and analytics that we are after. So many of you may not know, AWS has over the last decade become a major data provider. So this is a graphic from Gartner that talks about AWS being the highest in execution and furthest is in vision. Actually, last year AWS also surpassed Microsoft being the largest database vendor. And all of this is built on a global infrastructure where the data footprint is spread across many regions, many availability zones, which is needed to be a mission critical infrastructure for how businesses build on data and build on the innovations that data empowers. So this is a snapshot from a few months back of AWS's global footprint of about 102 availability zones. Availability zones, think of these are independent data centers that comprise a region. A region can have somewhere between 3 to 6 availability zones. AWS is in 32 geographic regions, and in addition, in order to get to low latency access to various application scenarios, AWS also has what is called local zones or wavelength zones as well. To give you a glimpse of the scale at which database services at AWS operates, there was a Prime event a couple of days back. We don't yet have the stats from there, but there was an event from earlier this year, the Prime Day from 2023, where AWS's key value store, DynamoDB, it served trillions of calls, giving a consistent single-digit millisecond requests, peaking at 126 million requests per second. Amazon has has a relational database service which is compliant with Postgres or MySQL, two of the more popular database services. And there are about 6,000 database instances that are serving billions of transactions that are powering these major events like Prime Day. And this is only just one customer that AWS has, which is Amazon internal. There are many major businesses that are running on AWS across bringing in the diversity of the workloads as well as the scale of the workloads. So data management over the years has diversified quite a lot. Right? And what this slide talks about is some of the diversity of the workloads that we see, from transaction processing, analytics and warehouse, NoSQL, time series, graph, in-memory, vector is the latest hottest trend now. Blockchains used to be the hottest trend a few years back. And all of these diverse trends, as the industry emerges, these diverse trends need to be supported to meet with the hundreds of thousands of customers that AWS has. And what this graphic shows is that how customers bring together these different diverse sources of data into a centralized place to drive the analytics that serves their businesses. Right? What this figure is showing is that the data lake or the analytics, how the analytics portfolio connects with the different types of purpose-built databases that cater to specific workloads, and then the data lake or the analytics web services is what drives some of the insights across the machine learning, visualization, for your training workloads and so on. So there are innovations that happen across the stack in order to help power some of these major services and also help innovate in terms of on behalf of the customers. So I'll be presenting a few of these during this short talk. So I'll talk a bit about the silicon and networking innovations happening at AWS, how the systems and storage layers are benefiting from that, and how analytics is building on top to create much more higher level value added services. And there are a lot of other things that are also happening that unfortunately I won't be able to talk about. So some of you may know AWS has invested heavily in its silicon innovations. So there is the Graviton family of processors that compete in the mainstream. So one of the major things about Graviton is its power efficiency. As we talked a lot about hitting the power wall and the power footprint driving the scale. Some of the largest regions in AWS, we want to be power efficient and we want to be effective in terms of how we use. And Graviton really pushes the boundary in terms of general purpose CPUs that help improve the price performance as well as the power efficiency. So for instance, Graviton 3 processors are 30% better price performance and power compared to the previous generation of processors, which were the Graviton 2 processors, and these keep on getting better. AWS also invested in the lower layers for hypervisor as well as networking virtualization and actually implementing it in hardware, the Nitro system, which does virtualization and offload of in hardware that allows us to run the customer workloads at bare metal speed and efficiency while giving this latest and greatest security characteristics that we expect from the virtualized environments. And we run a broad class of these workloads in our cloud servicing these different use cases. And we talk a lot about machine learning in many of our talks. AWS has also invested in, again, power efficient and scalable specialized instances called Trainium for machine learning training, as well as Inferentia for machine learning inference. To give you a glimpse of how the networking has enhanced in AWS, starting from about 10 gigabit network in March 15 to the latest announcements around EC2 P5 instances, which are designated for HPC or for machine learning training as well, supporting 3,200 gigabits per second using the Elastic Fabric adapter, which is, again, as you see, as the years are progressing, newer and newer generations of the technology is coming in. So what this has enabled is that some of these innovations that we are doing at a lower layer and building from the lowest layer all the way up to the higher layers of the stack, it has enabled creating some of the major innovations in our services. So Amazon Aurora is an enterprise-grade cloud-native database that AWS pioneered that kind of created a slew of additional database services from other cloud vendors as well. And one of the things was it was based off is OLTP working off of decentralized or disaggregated storage that gives you the speed and availability of the commercial databases, but also the scalability that you get from the disaggregation, and it was delivered as a managed service. So many of these innovations at the networking and the storage layer has helped power this to make it performant, like what databases were used to be in a single machine, but taking it and spreading it over the network. What you are seeing here is that in Aurora, how it works across multiple availability zones. Again, availability zone is a data center. AZs are forming a region. These AZs are separated across different flood zones, kilometers apart, so that they can have independent failure modes, but also have low latency that is low enough that you can build these kinds of applications on top. And what Amazon invested on is the storage layer that is disaggregated and spread across multiple AZs to create the durable and highly available storage foundation that you build on top on the compute tier to deliver the API compatibility that applications have come to get used to in terms of Postgres or MySQL compatibility. So this started off as a managed service, and this was a major innovation back in the back when Aurora was launched, as it enabled MySQL and Postgres workloads to get the enterprise grade the scaling and the performance characteristics. But as the workload evolved, they wanted to be more dynamic, and there was a continuous ask for this infrastructure to be much more dynamic and elastic. So a couple of years back, AWS announced Aurora Serverless, the next iteration, the second iteration of serverless, which is called Aurora Serverless V2, which supports that instant scalability and performance while delivering up to 90% cost savings for workloads that are bursty in nature. So instead of provisioning your infrastructure for your peak, you change your infrastructure resources on demand, but you do it for a highly demanding OLTP application that has very stringent latency requirements, while supporting the SQL surface area and giving the security guarantees that you expect from these enterprise applications. So for instance, Aurora Postgres, it has support for thousands of extensions that are written in native languages. That gives us very significant security footprint for us to manage, because we have third-party applications being developed on top of that, and we have to treat them as untrusted that could potentially be breached. So you have to give this elasticity while giving the performance and the security characteristics. And a lot of it was done in conjunction with innovations happening in the database tier, as I'll talk about, how it interplays with the operating system, how it interplays with the hypervisor, all the way up to the Nitro virtual cards that I talked about in helping to deal with the elasticity of the workload. So what is the problem that we are after? We have a client application that is sending the request to the database engine, and we want the database engine to grow and shrink. The database engine sits inside a guest operating system, sitting inside a virtual machine, sitting inside a physical machine, in a cluster within a data center. So, and what we are after is to optimize how much CPU to allocate, how you allocate the memory, how much temporary storage resident on the machine, as well as remote, and so on. And you want this to be resizing online, so that as your workload grows, not only do you have to increase the size of your database instance, you also have to grow your operating system as well as the hypervisor. So this includes CPU and cache sizing, scheduling algorithms to help isolate the workload as the demands change, requesting more memory from the operating system as need be. And similarly, on the other side, the database systems are designed to work with a huge amount of memory because they were designed to be working on a single machine. So how do we have these database systems also give up memory as well as grow memory? And you want to be able to grow within the realms of an instance, but as physical instance is also serving multiple different workloads. So when you reach the limits of resources within an instance, you want to be able to migrate these workloads live from one instance to another instance. And as I said, you have to do it in a manner that is secure and that can serve the broad class of applications. So this is at an instance level. And as I said, there are innovations that happen across the stack within even an instance. And now we are managing a service with tens to hundreds of thousands of these customers, and we are looking at the cluster level trends in order to place and identify how to effectively co-locate these workloads so that you don't end up having to migrate them very frequently. So this was in the database layer. A similar set of innovations are happening on the analytics tier, and what you want is, from a customer standpoint, you're running your applications, you want highly available, durable transactional systems, but you're doing it to also get analytics and insights out of that data. So I'm going to talk about Amazon Redshift, AWS's flagship analytics service. So when Redshift was launched in about a decade back, it also revolutionized how data warehouses were accessed. Earlier, you would have to have very expensive upfront investment to get your data warehouse, and Amazon kind of pioneered the pay per terabyte or pay per petabyte model of getting resources. But back about a decade ago, this is how a data warehouse looked like. It was a cluster, tightly knit. You partition your data, you'd co-locate. It was built for efficiency and best performance in a small cluster environment. But as the variety of the workloads that we presented in some of the earlier slides that came in, there was the realization and the need to be able to scale this to this diverse class of applications while still having the performance characteristics that a single cluster would provide. So a decade later, this is how Redshift looks like, where it is a combination of many, many microservices. You still have a concept of a cluster that is at the core that is executing, but many clusters are working together. You move from local data into remote storage. And again, this is where the networking enhancements come in, where you can get to remote storage with low latency and high network bandwidth, so that you are able to get close to the local performance, and then also benefiting from the improving the memory bandwidth and the instruction set that we get from the processors to improve the performance of your workloads that are cache friendly. And then not only do you have to build the core of the infrastructure, you also have to bring in these diverse workloads. So as you can see on the right side, there are workloads that are coming into the data warehouse. Traditionally, it was more batch-oriented, hourly, nightly update kind of a model, to getting into more real-time, where the data is coming in streaming, data is coming in from the operational databases. You want to serve machine learning workloads for training, inference, all within the context of this analytics systems. So this slide kind of gives an overview of how some of these innovations has resulted in price performance. And this is one of the key differentiators that AWS put forward in terms of efficiency and in terms of the unit economics of the software that we sell. So the faster and the better your software run, the less energy you spend, the less resources you spend, and especially in an economic environment like we are in this year, this becomes even more critical. So what this graph shows is the out-of-the-box performance without any tuning, and on the right we have the tuned performance. The graph shows the different cloud warehouses, Redshift being the first, and the three other alternatives that are there. And what you are seeing is the lower the graph is, the lower the bar is, the better the performance is. And this corresponds to a standard benchmark that the data infrastructure uses called the TPC benchmark. TPC-DS benchmark. And what you can see is that compared to alternatives, these steady stream of innovations have kept Redshift at about 3x to 5x better price performance compared to alternatives. I'll skip over this graph. This also shows about the concurrency aspect of it, that you can run high throughput workload compared to other cloud providers. But at the core of it, what is really enabling such performance and ease of use for our workloads? It is a combination of the advances that are happening in hardware that the systems are benefiting from, but also software enhancements such as automatic tuning. For example, using machine learning to tune your workload to automate the kind of tasks that administrators do. Identifying, analyzing your workload and identifying how to lay the data out so that you can minimize network transfers. You can automatically identify what data structures to build. Materialized views are a common data structure to use to speed up queries. Analyzing the workload to automatically recommend these materialized views, keeping them updated as the data is coming in so that the analytics that you're getting is most up to date and most real time. And this is how what happens is that when you see the overall analytics problem that our customers have, they have this broad class of applications that come in that want the data, because data is at the core of serving these models, serving these dashboards, serving the business decisions. And what this figure shows is that how all of these different bespoke services or the purpose-built services that AWS has built is coming in together to give that unified analytics story using managed storage or open data formats in S3, enabling machine learning use cases in SageMaker, transformation uses in Glue, as well as bringing in the data via these different modalities now, not only batch, but streaming or the general bandwagon of zero ETL, where your transactional data just shows up in your analytics system. So I leave you with this figure that, and also the broad class of services and the innovations. And as we say in Amazon, it's always a day one. It's continuing innovations happening even after a decade and more than a decade being in this space. And we are spread across the globe, not only in our data centers, but also in our teams. And this is where with the diversity of the experiences brings in even more innovations. So I'll leave you with that and open up for questions.
Off one. So relative to the other talks today, there is sort of a projection for what, say, how cloud workloads, particularly ML workloads, might evolve over time. And I think one of the points that you were making about how databases evolved over time was from more specialized environments to more generalized ones that try to that have more diversity of workload demands. I don't know if you wanted to speculate on what that meant for the kinds of things that either Stephanie or Dave were talking about.
Yeah, I think I am not an expert on the lower layers, but definitely on the upper layers of the stack that I operate in, having the benefit of be able to use reusable and commodity infrastructure that helps us give the scale and the efficiencies that we can get, right? So that really, so if you see a lot of these, a common theme across the different services is be able to identify what are those composable pieces, get the efficiency out of each in the different dimension, whether it's in hardware, whether it's in the operating system. AWS also has big investments in operating system work, in the security space, and then help build these services based on this composable infrastructure. One of the other things that we are also looking at is data. We often talk about machine learning in terms of training, in terms of the power, in terms of the efficiency and the power of the models, as well as our infrastructure. One common aspect that comes in is the data quality that feeds into the machine learning models, right? And that's another thing that we pay a lot of attention to, that as a business or as an enterprise where you want to derive the intelligence from your machine learning models, you get the data efficiently and in a high quality fashion so that the models that you train are also useful and effectively using the energy footprint that you are spending on these models. Yeah, so there is a lot of focus on being able to reuse these general purpose pieces and then specialize as and when we see opportunities at scale.
Other questions?
I'll ask one. It's a bit of an embarrassing question. I feel I should know this. What's a wavelength zone?
Very good question. These are basically what AWS is seeing is that there is more and more demand for the network to be closer to where the applications are. So data centers traditionally have been, even though they are spread across various different geographies, they are still like there are probably 2 or 4 or 5 regions within US, right? So then AWS went with the local zones, which are a bit closer to the workloads, and wavelength zones are supposed to be even closer for really low latency use cases and applications. And AWS is also investing in some like private 5G satellite networks and etc. So that is where building the infrastructure for the really, really low latency, really close to the workloads that are there.
Can you speak to what applications are driving that?
I am not the best person for that. I work way high up in the stack.
Okay, thank you.
Cool. Thank you for the opportunity.